So let's spend a little bit of time at looking at how these different steps work. So looking at the first step, this is where we determine the empirical formula for the molecule. We do this typically by using what we call microanalysis data or elemental analysis data, which tells us the percentage by mass of each of the elements in the molecule. So we're going to use ethanol as an example here. In this case, you can see the different percentages for carbon, hydrogen, and oxygen. And I've also given you here the atomic masses for these three elements. So what we do quite simply is take the percentage composition for each of those elements and divide it by its atomic mass. And you can see for each of these, we'll get a number, usually not a whole number. And the catch, of course, is we're trying to get the empirical formula. So eventually we need this, if you like, ratio of the elements to be integers, to be whole numbers. So the secret here is to take the lowest of these values. You can see in this case it's 2.17, and we divide each of those values by 2.17. That's going to bring us back to whole numbers and give us those integer values, which are going to go into the empirical formula, which, as you can see in this case, is C2H6O. Now in this case we know what the molecule is, it's ethanol. So we can verify that that's the correct answer. Bear in mind, in usual practices, you're not necessarily going to know what the identity of the molecule is. It's going to be some sort of unknown. So in that case, how do we verify that the empirical formula is the same as the molecular formula? And that, of course, brings us to step 2, which is where mass spectrometry comes in. There's all sorts of stuff you can get from mass spectrometry, but in this case, we're looking for one particular piece of information, and that's the molecular mass. The mass spectrum, as you can see, has lots of different peaks, and they all mean something, so that's probably a lecture for another day. In a mass spectrometer, the molecule breaks up into lots of different fragments, and each of these peaks you can see here corresponds to those different fragments. But we're really looking for the molecule when it hasn't fragmented, so it's giving us the full mass or the molecular mass for that molecule. And you can see in this example, the peak with the highest mass is at 46. That allows us to verify that C2H6O is actually the molecular formula rather than C4H12O2 or any of those other possibilities for the molecular formula. And sure enough, 2 times 12, 6 times 1, and 1 times 16, rounded off to the nearest integer, is going to give you 46. So we know in this case that it's not just the empirical formula, it's the molecular formula as well. So in the next video, we'll move on to how we use infrared spectroscopy.